A, B and C can do a work in 50 days, 100 days and 200 days respectively. So we'll just mark it here. A can do a job in 50 days. So every day A will do 1 by 50th of the work. B can do the job in 100 days. So every day B will do 1 by 100th of the job. And C can do a job in 200 days. So every day 1 by 200th of the work will be done. They started the work together, but A and B stopped working 25 days before the work was completed. So we will assume that the whole work was done in X days. And both A and B stopped working 25 days before the work was completed. So A worked for X minus 25 days, and every day 1 by 50th of the work was done. B also works for X minus 25 days. That is, B left the job 25 days before the work was completed. So 25 days less than X. And every day B will do 1 by 100th of the job. C worked till the work was completed. So C worked for the full X days, and every day 1 by 200th of the work will be done. Like this, in X days the whole work 1 was done. So we just need to solve this equation and calculate the value of X. For how many days did C work? C worked for X days. We just need to calculate the value of X. We'll multiply throughout by 200. That is the LCM of 50, 100 and 200. So all the denominators will go off. So 200 into X minus 25 by 50 plus 200 into X minus 25 by 100 plus 200 into this. 200 into X by 200. That is equal to 200. Now here 50 divides 4 times. Here 100 divides 2 times. 200 and 200 will cancel out. So here what we have is 4 into this. So that will be 4x minus 100 plus 2x minus 50 plus x is equal to 200. So here you have 4x plus 2x 6x plus x is 7x. Minus 100 minus 50 is 150. 150 to the other side. So there will be 200 plus 150, 350. 7 divides 5 times. So x you will get it as 50. So x is the number of days for which C worked, and that is equal to 50. So for how many days did C work? C worked for 50 days. Option B. The difference between the squares of two consecutive positive integers is 21. Find their sum. So assume that the two numbers are A and B. What is said is that difference between the squares, that is A square minus B square, and that difference is equal to 21. Now A square minus B square is A plus B into A minus B, and that is equal to 21. Now A and B are consecutive positive integers, so their difference A minus B is equal to 1. So basically what you get is A plus B is equal to 21. That is A plus B into 1, that is 21. So A plus B is the sum of the two numbers, that is 21. Find their sum, it has to be 21, option D. There are 2 boys and 3 girls. In how many ways can they be seated in a row such that all the 3 girls are seated together? So 2 boys are there and 3 girls are there. The 3 girls are always together. Whenever it is said that the 3 girls are together, you bring them together and tie them up and treat it as one. Then the 3 girls will always be together. So these 2 boys are there and this is treated as one person. So these 2 boys and this one person, so effectively 2 plus 1, 3 of them. They can be interchanged among themselves in 3 factorial ways. And in each of these 3 factorial arrangements, the 3 girls among themselves, they can be interchanged. They'll still be together. So 3 girls among themselves, they can be interchanged in 3 factorial ways. So these are the number of arrangements where the 3 girls are always together. That is 3 factorial into 3 factorial, option A. The total number of fruits with 3 friends A, B and C is 10. So you have 3 people A, B and C. Now we will assume that A has A number of fruits, B has B, and C has C. Now as per the first equation, the total number of fruits with three friends A, B and C is 10. So you have A plus B plus C is equal to 10. The sum of the reciprocals of the number of fruits with each person is 1. So if you take the reciprocals, that is 1 by A plus 1 by B plus 1 by C. And the sum of their reciprocals is equal to 1. So this is equal to 1. If A had the least number of fruits, then what is the difference between the number of fruits with B and C? So we need to find out B minus C. That is what we need to find out. Now here you have A plus B plus C is equal to 10. And 1 by A plus 1 by B plus 1 by C is equal to 1. So you have to try various values for A, B and C. And you can see that the only possible values are 4, 4 and 2. So if you assume it is 4, 4 and 2, 4 plus 4 plus 2, that is 4 plus 4, 8 plus 2 is equal to 10. It satisfies. Then 1 by 4 plus 1 by 4, that is 1 by 2 plus 1 by 2, that is also equal to 1. So these are the only possible values, 4, 4 and 2, such that these two equations are satisfied. So the fruits that they had are 4, 4 and 2. If A had the least number of fruits, if A had the least number of fruits means A should have 2 and the other two values will be 4 and 4. What is the difference between the number of fruits with B and C? That is 4 minus 4, that is equal to 0. So their difference is 0. Option A, 0. S is a group of 4 numbers, 1, 2, 3 and 1. I'll just write it down here, 1, 2, 3 and 1. In every step, 1 is added to any two numbers in the group. In how many such steps is it possible to make all the 4 numbers equal? If they are all equal, we'll assume that each of them is equal to x. Now, if you add up the 4 numbers, it will be x plus x plus x plus x. And their total sum will be 4x. So, if they are all equal, then their total sum can be represented as 4x. That is, the total sum will be a multiple of 4. 4x is a multiple of 4. Now, in this case, the total sum is 1 plus 1, 2, 2 plus 2, 4, 4 plus 3, the total sum is 7. So, initially the total sum is 7 and one requirement is that the total sum should be a multiple of 4. Now, at the end of the first step, it will be 7 plus 2. So, the total sum will be 7 plus 2 is equal to 9. At the end of the second step, it will be 9 plus 2. 1 is added to 2 numbers. So, sum will increase by 2. 9 plus 2, it will be 11. At the end of the third step, it will be 11 plus 2. The total sum will be 13. At the end of the fourth step, it will be 13 plus 2. The total sum will be 15 and so on. So, you can see that the total sum is always an odd number. It is never a multiple of 4. And one requirement for all the numbers to be equal is that their total sum has to be a multiple of 4 and it can never be a multiple of 4 because they are always odd numbers. So they cannot be made equal. So correct answer is option D, not possible.